I'm going to talk on REM sleep function, an evolutionary perspective. Sleep in the wild provides insights into sleep function not available under zoo or constant laboratory or sleep deprivation conditions. Although we tend to think of sleep duration as constant, once animals reach adulthood, sleep varies with season and temperature. Even in humans, you see a large difference between winter and summer sleep duration. In the wild, animals that are feeding or looking for food will have changes in their sleep. During mating, it's been shown that for a period of as long as 2 weeks, there can be reduced sleep during mating and predator-prey conditions. If an animal is vulnerable, obviously sleep will be reduced. If a predator is hungry, sleep will be reduced. So we recently studied sleep in the wild in African elephants. These animals have the smallest amount of sleep of any land mammal. Here you can see two elephants that were recorded for 35 days. Their activity was recorded. And you can see that there are some days in the first elephant at the top where it doesn't sleep at all. There's 2-3 days where it doesn't sleep, so it's kind of an elephant all-nighter where they're awake for 36 hours or longer. There's very little rebound after that. They just go back to the prior amount of sleep. And here's a second elephant recorded at the same time, also occasionally skipping a day's sleep and being continuously active. And over all the days, what you see is that the periods of inactivity occur towards the end of the night when it's coldest. So African elephants in zoos sleep 4 to 5 hours a day, but the African elephants in the wild that we recorded here have an average sleep duration of 2.1 hours a day. They have the largest brains of any land mammal and a reputation for intelligence and excellent memory. And they also live much longer than elephants in captivity, who sleep twice as long. In the wild, they are nearly continuously eating, looking for food, or drinking. So all of these qualities of elephants are in harmony. They get very little sleep, but they're very smart, and they get very little sleep, and they live a long time. And as I pointed out, days with no sleep are not unusual and are not followed by sleep rebound. And most sleep occurs towards the end of the night. So that's the animal with the least amount of sleep. The animal with the most amount of sleep, there are actually two of them, are the little and big brown bats, which both sleep about 20 hours a day, the most of any mammal. Now, these bats eat insects, which only come out of their nests at dusk, and they will consume these insects. The insects go back to their nests as it starts getting colder, and the bats, not surprisingly, go to sleep. And so I think you can understand the 20-hour sleep duration of the bat, again, as an ecological adaptation. It, the safest thing for a bat to do when it's not eating is to be on a cave wall or on a tree where it's relatively safe and it's not using a lot of energy, which would not be the case if it stayed out later at night, because it would use a lot of energy and have very few insects, or if it came out earlier where it itself would be prey for predatory birds such as eagles and hawks. So the sleep pattern is consistent with the food availability in the sleeping site, you can understand why they sleep as much as they do. Now, brain size is not correlated with total sleep time, and it's very weakly and negatively correlated with REM sleep time. So here you see the brain of the bush-tailed possum. They sleep 18 hours a day, 6.6 hours of REM sleep. And here's the elephant brain. And you can see that we don't know exactly how long elephants have REM sleep because that hasn't been studied, but we know it's certainly less than 2 hours. Now here's to scale pictures of brains of various mammals. So here's the human brain. The elephant brain is considerably larger. The dolphin brain is also larger than the human brain. And the blue numbers are the total amount of sleep, and the red are the amount of REM sleep. And you can see that there's not an obvious relationship, certainly not a positive relationship between brain size and REM amount. The animal with the most REM sleep is actually the platypus. That has a relatively small brain, but it has 8 hours a day of REM sleep, more REM sleep than our total sleep, than human total sleep. Cetaceans, whales and porpoises, have no REM sleep and about 4 hours of total sleep. This is updated from something I published in 2001. The left side of the figure shows animals that have more REM sleep than humans, and the right side, animals that have less REM sleep than humans. So the main point of this slide is that humans do not have an unusually high or an unusually low amount of REM sleep, despite our unusual characteristics, including thinking we're very smart. But you see, the animal with the most REM sleep is the platypus. And the animal with the least REM sleep is the dolphin, which in fact has no REM sleep. So that's one point to take from this figure. A second point is that the animals that have a lot of REM sleep also have a lot of non-REM sleep. We tend to think that these are completely independent states, but this is simply not the case. All of these animals on the left, although they have more REM sleep than the animals on the right, they also, and that's how they were selected, they also have more non-REM sleep. And a third point to take is that if you look at these examples, there's no obvious correlation between amount of REM sleep and intelligence, which is nicely illustrated here by the sleep parameters of a guinea pig and a guinea baboon. They're identical. One thing these animals have in common is that they're largely herbivores, and I think that is probably a better clue to how much sleep they're going to have, and therefore how much REM sleep they're going to have. So the amount of REM sleep is significantly correlated with the amount of non-REM sleep. The more non-REM sleep you have, the more REM sleep you have. And of course, we know REM sleep normally follows non-REM sleep. Now, this is the platypus. There are two egg-laying mammals, the platypus and the echidna, and I've studied both of them. The platypus hunts in the water, but it's not, it's not a fish. It has to come up to breathe, and they hunt these little crustaceans or worms. The crustaceans are called the abbees. And this is an EEG of a platypus. And you can see during this sleep period, although the EEG voltage can be high, the animal can have REM sleep. And this is very much like neonatal sleep in humans, which is often called active sleep because it doesn't look exactly like REM sleep. You have slow wave activity, but you also have rapid eye movements. And sometimes rapid eye movements are occurring during relatively low voltage activity. And sometimes you have high voltage activity without REM sleep. But this state in which you have rapid eye movements is occupying most of the rest time in the platypus, 8 hours a day of REM sleep. And the echidna also has that same pattern of activity. If you look in the brainstem of the echidna, you can see this tremendous activation during sleep in the brainstem, just as occurs in all other mammals. So now I want to show a video of a platypus sleeping. What you'll see is a platypus, when they're swimming around, they move their head left to right. And this is to scan the environment because their bill is electroreceptive. That's how they detect animals. They really don't have very good vision. So here's the platypus in its tank. You'll see the yabbies, which are these freshwater crustaceans that they feed on. They crush them and then can eat the meat. And here's what platypus REM sleep looks like. You can see it's very active, really just like a human baby. Huge amount of activity in the eyes, and here you're seeing it more obviously in the head and the jaw. You see the same side-to-side movement you saw as it was swimming around. So I wondered, why do monotremes, the echidna and the platypus, have so much REM sleep? Certainly the brain size and brain body weight ratio are not unusual. There's no evidence that they have extraordinary cognitive abilities, but their body and brain temperature is 31 degrees centigrade versus 37 in humans and other placental mammals. So I thought that might explain that. And here's a measurement of what happens during REM sleep in relation to temperature. Parmigiani was the first to see this, and this is a recording that we made more recently. And you can see in REM sleep, temperature goes up. This is cortical temperature, but it would be true for all brain temperatures. And in non-REM, it goes down, non-REM or slow wave sleep. So it's as if the brain temperature going down in REM sleep is reversed by following it with REM sleep, which raises the brain temperature back closer to the waking level. And this is a figure from work by Juvet in 1990. He established that REM sleep was generated in the brainstem. You can literally take all of the brain rostral to the pons out of the body, and you'll still get REM sleep. But what he found in this experiment, I never spoke to him about this, whether this was an accident or not. When you have animals with the brainstem severed in this way, they don't regulate their brain temperature. So you need to keep them on a heating pad to maintain the 37-degree temperature. But if the heating pad isn't working, the body temperature will fall to room temperature, 23 degrees here. And what Juvet observed is that under these conditions, the amount of REM sleep increases tremendously. So the normal amount of REM sleep in a cat is about 15% of the total time. But when the core body temperature is allowed to fall, it goes up to 80%. So very consistent with this idea that, excuse me, REM sleep is triggered by low temperature. Cold brain stems and cold monotremes have high levels of REM sleep. So I was asked to review this work last year, and I decided to plot this out, and to my amazement, actually. If you look at the temperature relations across orders of mammals, including also birds, you see that monotremes have this very low 31-degree body temperature, marsupials 35, placentals 37. Now this is true of all placentals. A mouse and an elephant, both about 37 degrees, and birds have the highest body temperature. And if you plot the amount of REM that's been reported in these animals, in these orders of animals, there is an amazingly strong negative correlation that the higher the animal's body temperature is, birds being the highest, the lower the amount of REM sleep. So this correlation is minus 0.975. You don't see many correlations like that in our business. So here are my hypotheses on mammalian sleep. The major determinant of sleep duration across species is ecological, an adaptive reduction in brain and body energy use constrained by the waking time needed for food acquisition. Next to the heart, the brain uses the most energy of any organism. There are high amounts of REM sleep in monotremes, and these may be a consequence of their low body temperature. And contrary to the way most of us have been thinking about this, as REM sleep is a newly evolved state because it was only discovered recently, it's dominant in the most primitive mammal, which suggests that, in fact, non-REM is the more recently evolved state. Monotremes, basically, they go to sleep and their brain stays warm during REM sleep, and then they wake up. But in placental mammals, you have this oscillation between them. And I hypothesize that REM sleep evolved to reverse the brain cooling and associated metabolic reduction that occurs in bilateral non-REM sleep. So REM sleep, of course, follows, and its duration is correlated with prior non-REM sleep. In hibernation, REM sleep is suppressed, also consistent with this idea that REM sleep warms the brain. And REM sleep facilitates alert waking. If you awaken from REM sleep, you're much more alert than if you awaken from non-REM sleep. Dave Dinges and others have shown this. And in contrast to homeotherms, we did study in the turtle and find no activity in the brainstem during quiescence. There just is no period of activation. So again, consistent with this idea that these cold-blooded reptiles that don't need and don't have REM sleep. So I recently located videos of Asarensky, Kleitman, Juvet, and Dement's talks at the symposium honoring Kleitman on his 100th birthday. This was in Nashville and in 1995. And these tapes were quite literally lost for 25 years. But through a series of accidents, I was able to find them, and they're on my website. So you can simply go to this URL, or you can Google my name, UCLA, and website video, and you'll see their talks on REM sleep and the discovery of REM sleep. And these are also now on YouTube. So if you use the right search terms, you can come up with these. So thank you very much for your attention.